All right, let's take a look at some basic matrix operations. So what is a matrix? A matrix is a rectangular arrangement of numbers. It could be variables also. We're just going to be working with mostly numbers in rows and columns. Okay. The symbol for a matrix is this little, like a bracket looking thingy. And of course the numbers and variables are arranged in rows and columns. So the first thing we're going to look at is multiplying a matrix by a scalar. So a scalar, this is just a vocab word. Okay, it's just a vocab word. And what is a scalar? It's a real number. It's basically a number. What do? Well, we're going to multiply the scalar by each entry in the matrix to get the answer, the product matrix. So let's do that. So we're going to multiply the -3. So we're going to open up a new matrix. So -3 times 1 is -3. -3 times -3 is 9. -3 times 6 is -18. -3 times 9. So basically we're just doing this. We're multiplying it each way, just distributing it. Okay. Let's see. -3 times 9 is -27. And then -3 times -1 is 3. That is so weird. Why it's disappearing like that? Who knows? -3 times 4 is -12. So our answer is this. That's our answer matrix. Okay, so hopefully that makes pretty much sense. It's not too bad. We're just going to distribute through. Let's do that to this one. All right, so let's see. -8 times 0 is 0. -8 times 1/2 is -4. -8 times -2 is 16. -8 times 1 is 8. -8 times 4 is -32. And last but not least, -8 times 3 is -24. All right, so that is simply multiplying by a scalar. Yeah, not too bad, right? Okay, great. Let's move on. So the order of the matrix is a really big deal. It's always rows by columns. Always rows by columns. Not columns by rows, it's rows by columns. So let's look at matrix A. Matrix A is let's see, there's 2 rows by 3 columns. That's a 2 by 3 matrix. Okay, that's good. So matrix B, I have, rows is 1, 2, I have 3 rows by 2 columns. See how very different they look. Really important to know the order of the matrix. So rows by columns, always. Now how can you remember that? I don't know, it's opposite of alpha order, right? C comes before R, so maybe that will help you remember. The rows come first and the columns come second. All right, one more slide. Now that we know how to multiply by a scalar, we're now going to look at adding and subtracting matrices, just in general. And something we need to keep in mind, and that you can only add or subtract matrices of the same order. Like a 2 by 2 can only be added to a 2 by 2, a 3 by 3 to a 3 by 3, and so on. That's all we can do. So here, and what do? Well, to add or subtract the matrix, we add and subtract the corresponding entries. So what's a corresponding entry? A corresponding entry would be, that is so crazy, like if we look at the order, so this location would correspond to this location. You know, the top row, you know, the first column, that they correspond to each other. Kind of like corresponding triangles, right? Ooh, remember that geometry, corresponding triangles? The parts of it, like a corresponding angle. But they correspond. In this case, they're in the same location in the matrix. So we would simply add that up. 0 plus a negative 1 will be negative 1. 2 plus 3 is 5. Then I have 2 plus a negative 2 would be 0. And then negative 5 plus a 4 is a negative 1. And this would be my answer. Okay, not too bad, right? Now on B, that just doesn't look right. Does it look right to you? That just doesn't look right. This is a 2-row by 3-column matrix. This is a 3-row by 2-column matrix. And those aren't the same order. They're not the same order, so that's going to be impossible. We can't do that. That's impossible. Impossible. Okay, so now let's get to some that are a little bit more complicated. On C, oh, we got a lot going on there. Let's see, the parentheses, we need to follow order of operations. The parentheses say to do that part first. Okay, so let's do that. So we're going to keep the 2 out there, and then we're going to well, there's several ways we could do it. I'm going to do the inside part first. So it's going to be 2 times. So we've got our 1, 3, 2, 4. And then I'm going to distribute, if it lets me, I'm going to say plus because I'm going to distribute the negative 3. So negative 3 times 5 is negative 15. Negative 3 times a negative 7 is, what is that? Negative 3 times a negative 7 is a 21. Negative 3 times a negative 6 is an 18. Negative 3 times an 8 is a, what, negative 24. And then minus 5. Well, we'll go ahead and distribute the 5. Why not? That looks fun. So negative 5 times 0 is 0. Negative 5 times negative 2 is 10. I almost feel like I have like a, I don't know, one of those strobe lights going on. It's so weird. Negative 5 times 1 is 5. Negative 5 times negative 3 is 15. Okay. Let's see. So let's go ahead and add together those 2 on the inside. Let's see. 1 minus 15 is a negative 14. 3 plus 21, what is that, 24. 2 plus 18 is 20. And 4 minus 24 is a negative 20. And then plus 0, 10, 5, 15. Okay, now we're making progress. So let's distribute the 2. Whew, finally get rid of those parentheses. So 2 times negative 14 is negative 28. 2 times 24 is 48. 2 times 20 is 40. And 2 times negative 20 is negative 40. Okay, plus 0, 10, 5, 15. Whew, okay. So let's shrink this up just a little bit so I can fit it. Gosh, don't you love that part? It's great. Okay, so now let's finish up. So we should get our final answer of negative 28 plus 0 is negative 28. 48 and 10 is 58. 40 and 5 is 45. And negative 40 plus 15 is negative 25. Yay! And that gives us our answer. Whew, okay. Oh, let's look at our very last problem. That is interesting. We've got a variable in there. Ooh, okay, this looks fun. So we're going to solve for x. Okay, so on the left side we got an equal sign. Wow, we haven't seen one with an equal sign before, but that looks fun. Okay, we got this. So we're going to work on the left side and we're going to add these two matrices together. So 3 and 8 is 11. 6 and 1 is 7. Ooh, look at there. It's lining up. Isn't that cool? I like that. So 8 and 10 is 18. And wow, it does correspond to 18. Wow. So then we have negative 5 minus 4x is 19. So that's how we need to work that through. We need to kind of focus on this location and this location. We need to set those equal to each other. So negative 5 minus 4x equals 19. So I've got negative 4x equals, I add the 5 over, what does that give me, 24. So x is going to be, what, negative 6. All right, fantastic.